All right, we're going to cover lesson 2.5, radicals, equations, and absolute value equations. All right, now with this right here, there's a couple things you have to kind of get to understand and to remember. And what I mean by that is, like, for example, can you ever take the radical? Let's say I have something like this, right? Can I ever take the radical of some number and get a negative value? That's always ultimately the question, right? I mean, I can't take, for example, the square root of something and get negative 16. It doesn't happen. So if ever you're attempting to take a value of a square root of something and it's yielding a negative value, you can say does not exist. Now, that is just the nature of this, because if what we're going to do is we're going to go ahead and square both sides, right? And then you can't go ahead and square this without getting a positive value, all right? And then that will give you a number that isn't sufficed or that does not solve the problem. So it's a throwaway. The answer cannot exist. And that happens with radicals. So you have to test your value, all right? Now, in this case right here, when you're looking at negative 4 plus negative 2 times the radical of x plus 4 equals negative 16, well, we go ahead and add 4 to both sides to, get this radical by itself, because you've got to get it by itself. You're going to get negative 12, and then you're going to go ahead and divide by negative 2. Now, when that happens, you're going to get a positive 6 over here. Now, we can take the square root of a number and get 6. As a matter of fact, it would be 36, right? The square root of 36 is 6. But we're going to go ahead and do this, right? Where we take and get this, we square both sides. That'll knock that out. That leaves us with this. And then we're going to go ahead and subtract 4 from both sides. So when we put 32 back in here, 32 plus 4 is 36, square root of 36 is 6. So this is the answer we're looking for. And it works for the original equation after we looked at it, because this right here, if we keep on going backwards in the process, we'll get back to it working. All right, so it's what we need to solve for this is 32. All right, now that process continues with different scenarios, but the opposite of a radical is squaring something. So when you have this, we follow the procedures that since we have an isolated radical, we go ahead and square both sides. And that gets rid of the radical symbol. Excuse me, I got to get rid of the radical symbol. And so we have this. And then I got to go ahead and solve this. I got to bring this all over to the other side and get this. Ask myself what two numbers multiply together create negative or positive 3 that add up to positive 4. Excuse me, I have a frog in my throat. Okay, so we're going to go ahead and isolate that or factor it. All right, and then we go ahead and say, well, x has to be negative 3 or negative 1. Now we're going to go back and put this back into the equation, right? So we go ahead and put it in here. And again, I say to you, okay, there's no two numbers that there's no single number that when we take the radical of it, it's going to yield a negative value. So when we go ahead and put negative 3 into the equation, the original equation, you're going to get negative 3 equals some value of who cares, question mark. You can't take the square root of anything and get that number. Same goes with negative. You can't do that either. That's a question mark because it doesn't matter what it is. So both of these are throwaway answers. So we gotta go ahead and see that the answer is DNE. Does not exist. All right. So we just want to make sure that we're checking our answers. Solutions that are yielded or produced by the process but don't work for the original equation. So that's why I began with the statement earlier. It's like, can you take the square root of any value and get negative value? And once you get past that hurdle, then most of the time it will work, by the way. But there are domain restrictions on radicals, and that's why you have to be careful with it. All right, so let's take a look at the next. All right, we have this. We're squaring both sides. And it's kind of like this process over here. We're just going to bring over the 8 and the 33 and ask ourselves what two numbers multiply together to create negative 33 that add up to negative 11. Or, excuse me, whoops, I kind of gave it away a little bit, but negative 8. And we have negative 11 and 3. And we're going to get x equals positive 11 and x equals negative 3. So we automatically know that the negative 3 is a throwaway because, again, it's like almost like this situation. It already has an isolated variable x, so that's not going to work. So our answer will be 11. Now, if we go ahead and do the math in that, then it would be 33, and then it would be plus 8 times 11. All right, that'd be 88. 88 added to 33 would be 121. Therefore, that would work. All right, because the square root of 121 is 11. So it works. All right. Now, this process is repeated several times. All right. You go ahead and subtract 4 from both sides, square both sides, and then go ahead and isolate for the variable x, and then check your solution. All right. Things like this, you would go ahead. Now, this one right here, again, cannot exist because there's no, this is already isolated and you have a negative value. So the answer is DNE without even going any further. I don't even need to do this problem. And I know it's DNE. It does not exist because there's no such number I could put in here that's going to give me the square root of some number to equal negative 1. So that's like almost a gift. All right. So you take a look at some of these problems. I mean, let's take a look at number 6. All right. I'm almost done with this section because its process is very similar to every single other process that I do. Just different numbers. You should get the concepts. You go ahead and isolate the radical. And then we square both sides. We isolate everything to one side of the equation. We factor. And we notice that that's not the factor that works for this because this does not add up to positive. Yeah, this doesn't add up to that. Let me see. What did I do? Subtracted that. Subtracted that. Yeah, that does not work for the original equation. So we're going to get, yeah, this doesn't work because that's not the factor form of that. So you're going to get some weird answers. Okay, that this doesn't seem like it's working right. Let me see, what did I do wrong? Because I did something wrong. Oh, here we go. This is what I did wrong. That's 1 times 1 is not 2. I added it accidentally. I knew it did something goofy. Okay, now this is going to be, this is a factor. Yeah, this is going to be, okay, that's going to be this, and then that's going to give me the negative. Okay, that's what we wanted. My apologies. I did goof up something. So here we have this. Okay, now that works because this one right here, when we go ahead and isolate it, this means x equals -2 and x equals +1. We put in +1 in here and it'll be -1. Therefore, you can't go ahead and figure that out because you're going to get -1 minus 1 is going to give you -2, and the square root of -2, square root of anything is then going to give you a -2. So I'm going to write that down because some of you are like, you're going too fast. You're going too fast. So you put in -1. All right. Well, actually, it's +1. This becomes a -1. All right. Now that's going to give you +1. This is going to go ahead and give you 4, square root of 4. And when you go ahead and subtract 1 from both sides, you're going to get square root of 4, all right, equals -2, and there's no way that that will work. So that that number right here, 1, will not work. Therefore, we throw it out, okay? And then we're going to be given the value of -2. And that's the answer we're looking for. Okay, this one's a pretty important question. You might see this again on your test. Even though I might have goofed it up a little bit because I accidentally added -1 and it got 2. That's not right. It's 1. I made a mistake here, and then that threw everything off. I don't know why I made a mistake, but it happens. But don't let it happen for you. All right, now I'll cover this right here. I'll cover this problem. Okay, so now x is raised to the 4/5 problem. You have that. Now the way to get rid of exponential functions well, not exponential, well, the power that has a rational exponential power. All right, in other words, a fraction here. We go ahead and there's a couple ways you can do it, but I would say go ahead and raise everything to the denominator. All right, and then go ahead, once you have that, this will knock this out and leaves you with the 4th power, or the x to the 4th power, and then you have 256. All right, raised to the 5th power. I'm not actually even going to do that yet. All right, because what I got to do is go ahead and then take the 4th root of both sides. Now, when I take the 4th root of, that means I'm going to do this. Because one thing you need to understand is that the 4th root of is really this. All right, it's 4th root is 1, or x to the 1/5 power. So that's just another way of writing it. And so when you do that to something that's raised to the 4th power, that power then becomes the numerator. Then this becomes 1. Well, the reason why I wrote it that way is because I got to go ahead and do this. Now, rather than doing it that way, there's probably a little easier way of doing it because that seemed a little confusing. If you have a power that's 4/5, why don't we just raise it to the 5/4 power? It's the reciprocal. That seems to be a little easier to use, that concept. All right. Now, what does this mean? All right. What does this mean? Now, what we could do is take our calculators. We don't even need to do much here. Okay. All I say is to take the fourth root of 256 and then raise it to the fifth power. So another way of writing this is this way. There's multiple ways we can write this, but this is one that we can do. Okay. Now, we have this. We're going to go ahead and use our calculators and just simply take the fourth root of 256. Now, with this particular calculator, I can hit math and see where it says x to the, oh, I got it too bright. See where it says we have x right there. Let me autofocus that. Okay, see where we have x radical sign? Well, when you hit that, right? When you hit that enter, it allows you to raise it to the not raise it, but change the index of your radical. So we can take the fourth root of 256 and get 4. And then take 4 and raise that to the fifth power. And then there's our answer that we're looking for. All right. Now I'll explain the plus or minus sign in just a second. So I just wanted to get that number for you, the 1024. Okay, now when we go ahead and take an even index, we have to put a plus or minus sign like that, by the way. It's just the nature of indexes with even, but we definitely want to take and get the plus or minus sign in there whenever we're taking radicals of things. And this is in fact a radical, okay, when we're doing this, okay. So I want you to get used to that concept, but this one is definitely something that is just a matter of learning how to use your calculator. Now, some of you might think, well, why can't I just raise 256 to the 5/4 powers? And that is true. You can do that. Now, watch this. Okay, I'm going to go ahead and zoom in on it. All right. Now, if I take and raise 256, watch that. I can go ahead and do this. Actually, I want to put fraction. Hold on. Oh, yeah, I know what I want to do. I want to come up here and I want to hit second. Oh, no. There it is. Second, or alpha y equals gives us fractions. All right. Now I do the 5/4. And that gives us our answer as well. Okay. Now we will, again, because we're dealing with even index, we have to constitute the negative and positive. See how that's even, the 4? Put a plus or minus in front of it. All right. That'll give us our answer that we're looking for. All right, now taking a look at this one. All right. We want to go ahead. I'll show you the answer is 37. Interesting. It's not plus or minus. It's just 37. The index, when we're going to go ahead and take, all right, we're going to take this. Let me see if I can get it to zoom in. Okay, we're going to go ahead and take 128 and raise it to the power of alpha y equals fraction. Okay, and then that's going to give us the reciprocal of 7/5 is 5/7. That's going to give us 32. Now, once we do that, all right, once we do that, we're going to go ahead and take and add 5 to both sides. So plus 5. And that's where the 37 comes in. Now, see how the index for this right here, I just want to point out, see how the index for this one was even for the denominator? This one was odd for the denominator. Notice how the answer does not have a plus or minus any value there. Only when it's even do you put a plus or minus. When it's odd, you put a just standard answer. You don't have to put the plus or minus. So it's just the positive value. Okay? It's whatever it is. If it was negative, it would be negative. If it was positive, it's positive. I'm just letting you know, but just be careful with that concept. I'm trying to explain it to you, keep it simple for you. Okay? Trying to give you a heads up. You might have to review that a couple of times. It's not easy to concept, right? The concept is easy. It's not easy to figure out. All right, enough with the radicals. Now I want to go into absolute values. Okay, we're going to talk about absolute value right now. Now, absolute value is the idea of distance away from 0. Okay, just get that in mind. The distance you are away from 0. Now, when you're doing this, okay, can think of it as 2 and negative 2 is still 2 units away from 0. Okay, just get that in your mind. All right. So let's go ahead and take a look at then the way you process this. You have to isolate it like you do everything else. You have to get it by itself. So bring this over to the other side. So add 8 to both sides. All right, and you get negative 36. And then you divide both sides by negative 9. And you're going to go ahead and get 4 here. So then you go ahead and think, well, this is going to be plus or minus 4, because you go ahead and take the opposite of this. Now, remember that the absolute value of anything is always going to be positive. So like the concept of radicals, right? You can't take and get a negative value outcome. You would say do not exist for such cases, because there's no such thing as an absolute value of something that gets negative. All right. So the answer here is plus or minus 4, because that is the distance you are away from 0. All right. So when you're looking at this, the next question, to solve them, all right, as long as it's positive here, okay, then all you got to do is go ahead and say this and then this. So you set it equal to the other side as well as to its opposite. All right. Now, when you're doing this, you're going to go ahead and just solve them like you do regular equations. You're going to go ahead and add 4 to both sides. All right, so let's make sure we copied that right. So adding 4, you get 20 or 33. And then subtracting 4 from both sides, you get this. Or adding 4, excuse me, you get this. All right. Now, when we go ahead and solve this one, pretty easy. It goes straight into it. We get x equals negative 5. And then going ahead and doing this, you're going to get a fraction. You're going to get 33 over 5. Now, we can leave it like this, all right, because we don't want to bother. going ahead and doing this. Now, thing is if we plug this back in, 33/5, we plug it back in, we take and wipe out the 5s, and it'd be 33 minus 4, and that would give us, in fact, 29. And then we go ahead and the same thing, put negative 5 in there. That'd be negative 5 times 5 would be negative 25. Negative 25 minus 4 is negative 29, and the absolute value of negative 29 is 29. So that's where you're going to get the 33/5, which we got. I was off the page, sorry. So 33/5, and then we get also the negative 5. All right. So absolute value, you must consider the fact that there's two different answers that could be resulted. I always tell students, though, before you even bother checking or doing any of this business, that if you're taking the absolute value of anything, all right, and you're equaling that to a negative value, then automatically does not exist as the answer. And we can try to see other examples of that. I'm not going to bother doing 14 because all it is dividing both sides by 8, getting the 3, and then going ahead and subtracting. And then it's the same process as this. I would like to do number 15. Let's see what that does. Okay. Trying to give you different examples, different looks. Now, I'm going to be honest. I know what's on the test right now, and I'm kind of targeting questions that are absolutely going to be questions that look like what you're going to have on the test. So you want to make sure that you're focused on these types of questions. So here we go ahead and we would go ahead and add 4 to both sides, or not 4, excuse me, add 8 to both sides. I'm seeing the 4s here. So adding 8 to both sides, you're going to get this. All right, we get negative 36. Divide both sides by 6. And you get this negative 6. All right. Now, I tell you right now, again, as I said before, that there's no such value that you can take the absolute value and get a negative value 6 from it. So the answer does not exist. I'm not even going to bother completing this question. All right, does not exist. It is really fast. Do not go through the whole process of, got to go ahead and set it equal to the other side and its opposite, and then go ahead and yield a couple different answers. Because once you put it into the original equation, it doesn't work, and then you wasted all your time. So I'd say that to students often, and then they still do it anyway because they're unsure of themselves. They don't have complete understanding about what they're doing. Okay. Now, I'll just do one more of these just to get the concept of that setting equal to the other side and the opposite and stuff. But it doesn't change the process. The process is always going to stay the same. So then this is going to be the setup. We're going to go ahead and add 4 to both sides. All right, adding 4 to that, and then we're going to divide both sides by 2. Divide both sides by 2, and then go ahead and now here's because with the absolute values, I'm setting equal to the other side. I'm going to take the absolute value signs away. All right, I take the absolute value signs away, and I also set the contents of the absolute value equal to the opposite of the other side. Okay, that's what we want to do for absolute value, is the contents of the absolute equal to the other side, as well as the contents equal to the other side, opposite of the other side. Now we go ahead and subtract 3 from both sides, divide both sides by 9. I get 4 9s, and do the same thing. I'm going to get 10, negative 10, and then divide both sides by 9. So I get my answer of 4 9s, and then negative 10 over 9. Now I want to just kind of look over and see that it looks like it would work. All right. Now you're always taking a chance if you do not check your answers, but I'm going to play on the fact that I can see that they both will work. So I'm going to provide the answers, and that it is in fact what we came up with, which is 4 ninths, negative 10 ninths. So I have the answers here that align to what I've given. But remember, with absolute value, you must go ahead and set equal to the other side as well as to the opposite. And that's the biggest thing you get with absolute value. All right. So that I'm going to go ahead and leave you to complete 17. And if you have any questions, just email me.